Okay, it is time to learn about something called the nth term test. So we use the nth term test to determine if an infinite series diverges primarily. Okay, and I can tell you what the test says. I'm aware of that. I could just go straight into it, but I'd rather get you thinking about something before I explain how this test is used and what it means. Okay, so I just want you to think about an example real quick. I don't think it'll be a very difficult example, but I want it to be on your mind. So you see this series right here, the sum from 1 to infinity of 0.5. Now notice there's no n in there. It doesn't say 0.5 to the n power. It doesn't say 0.5 times n. It's 0.5 is just a constant. And what it means is every term of this series is 0.5. 0.5 plus 0.5 plus 0.5 plus 0.5. Now, do you think this series will converge or diverge? Okay, well, how about this? Generally, what does it look like when a series converges? Well, this is a slide that I used in another video, but this series converges. And here's what I mean by that. That as you keep adding the terms together, as you do a half plus a fourth plus an eighth, as you keep going, then your grand total seems to hit a wall, all right? You can add forever. You'll never get to 1. You'll get right up against 1. You'll get as close to 1 as you can imagine, but you'll never actually get there. Now, this is not a mathematical proof that this series converges to 1, but I'm more concerned with giving you something that will convince you than giving you a mathematical proof. So I want you to look at this and say, all right, like this is roughly what a series is going to look like if it converges. The partial sums will tend towards a certain number, meaning the more terms you add, the closer your grand total gets to some number. A series involves adding, right? Adding forever. Okay, so back to this one. Do you think this series will converge or diverge? Well, I would think like you add 0.5 forever and you're just going to get a bigger answer the more terms you add. It's definitely going to diverge. I hope it's not too hard to see that. I mean, you have forever to add, and the more, 0.5 is not that big of a number, but if you keep adding it, you're just going to get a bigger grand total. Your grand total is not going to level off at anything. Like you add the first 2 terms, you add the first 3 terms, you add the first 4 terms, you add the first 100 terms, you add the first 1,000 terms, your answer just gets bigger the more terms you add. So the series is going to diverge, okay? All right. I just wanted you to think about that. All right, and it is kind of like for me to get off topic a little bit that even though you have forever to add these numbers, I know those numbers are getting smaller, but even though you have forever to add them together, you'll never get 1. You'll never get there. You'll just get as close as you can imagine. All right, now anyway, so let's think about yet another example. Okay. So now I realize I still haven't told you what the nth term test is, but I'm just trying to get you to think about some things so that hopefully you have the best chance of understanding it. See this series right here. It says the sum from 1 to infinity of n plus 1 over n. Okay? I wrote out some examples. First term's 2 plus, second term's 3 over 2 plus, third term's 4. You get the idea, right? What I notice about this series is that, do you see that thing right there, n plus 1 over n? The bigger n is, the closer n plus 1 over n is to 1. Meaning the limit as n goes to infinity of n plus 1 over n is 1. Okay? All right, so that means that in this series, the first term might be 2, and the third term might be 4/3, and so on. But the further out there you go, the more terms of the series you write down, the more that they start to look like 1, all right? That's what this means right here. As n gets bigger, that is going to look more like 1. Now, so what do you think then about this series? Would a series like this converge or diverge? So here's my reasoning on it. I think it's going to diverge. In other words, I don't think at all that something like this is going to happen. See this one? I don't think it's going to be like this. I don't think it's going to be the case that the more terms you add, the closer your grand total gets to 1. I don't think that's going to happen. Because, you know, at a certain point, you're adding 1 plus 1 plus 1 plus 1. And how long does that go on? Forever. So the more terms you add, the bigger your grand total is going to be without any limit to it. All right. So it's going to diverge. That's my statement. That's my reasoning. And, you know, I can tell that just because regardless, you know, it doesn't matter what these first few terms are, it's 1 plus 1 plus 1 plus 1 at a certain point forever. Okay, so a series like that is not going to converge. It's going to diverge. I hope then that one, even though the terms are all a little different, you see it a lot like this. Okay, yeah, if I add 0.5, even if that's not that big of a number, if I add it together forever, the sky's the limit, all right? Okay, so now I've got you thinking about what I wanted you to think about, hopefully, okay? Now, here's what the nth term test says. Nth term test is actually pretty simple, but I'm afraid if I didn't tell you those first few examples, that you would get this confused with other things the more we learn. Here's what the nth term test says. So suppose we have a series and it's an infinite series that a subscript n is just the formula that the series is made from, you know. So it could be, what was that one that we just looked at? N plus 1 over n or something like that. That thing right there, that formula, that's what I'm calling a sub n. Some formula that involves the variable n. If the limit as n goes to infinity of a sub n is not 0, then the series will diverge. Okay? Can you think about why that is? Well, if those terms level off to be some number but 0, then you're adding some tangible number to itself forever, you know? So like with this one, what's the limit on that as n goes to infinity? 1. What's that mean? Well, it means the terms look like 1 at a certain point. It's almost 1 plus almost 1. Well, you know, if that was any number, then you're just adding some tangible number to itself forever. So the series is going to diverge, okay? All right, so you take that formula. If the limit at infinity is not 0, the series diverges. What if the limit at infinity is 0? It's inconclusive. If this is what you get, then the series can either converge or diverge, okay? All right. So those are the two cases. This is the only one that tells us anything, all right? People are, for whatever reason, they're inclined to think that if the limit as n goes to infinity is 0, that must mean it converges. That's not true. This does not tell you it's inconclusive. The only way from the nth term test that you can make a judgment is if this limit at infinity is not 0. Let's look at some examples. And it'll be pretty black and white to decide from here. So I have a series of questions that says decide if each series converges or diverges. So look at this one. What is the limit as n goes to infinity an? Okay. Well, an is actually a constant this time. It's 2. You know, this series is 2 plus 2 plus 2 plus 2 is 2's forever. So I guess what I'm saying is, what's the limit as n goes to infinity of 2? Well, 2 is always 2, so that limit's 2, and that's not 0, okay? First part of the nth term test, if the limit at infinity of whatever that formula is not 0, it's conclusive then that the series diverges, okay? So this series, final judgment is it's going to diverge, okay? And then you think, well, obviously, if you add 2 together forever, you have a series that diverges. What about this one, cosine 1 over n? Let's try again. Let's look at this. What is the limit as n goes to infinity of cosine 1 over n? Well, if n goes to infinity, 1 over n will go to 0. So it'd be safe to say that the limit of this is cosine of 0. But cosine of 0 is 1, and 1 is not 0. Remember, the nth term test said if this limit is not 0, then the series will diverge. So long as you can do this limit, then it's not hard to make a judgment about the series, okay? What's another way to think about this, why this series diverges? What does this mean when I say the limit at as n goes to infinity of cosine 1 over n is 1? That means in this series, you'll get some pretty weird numbers at first. Cosine of 1 plus cosine of a half. But what happens if you keep going? Like, say you go way down there. Say that the n gets real big. What kind of number are you going to be looking at? Well, practically 1. You know, so the numbers are kind of weird at first. They're not nice round numbers at first, but eventually it's going to look like 1 plus 1 plus, well, I mean, you add 1 together forever. From here on out, it goes forever. Of course it's going to diverge. Okay? All right, now to do this one, in the video I made about sequences, I talked about some rules for limits. So let me remind you of one of the rules that we had then. So rule, limit n goes to infinity of a to the n power is 0 if a is between -1 and 1, and alternately the limit as n goes to infinity of a to the n is infinity if a is bigger than 1. Okay, so one of these rules there is operative here. So look at it like this. The nth term test says to figure out if a series diverges, you can investigate the limit as n goes to infinity of that. Okay? Now, pi over 3, what kind of number is that? Well, pi is slightly bigger than 3. So if you take a number bigger than 3 and divide by 3, then you'll get a number that is bigger than 1. Okay? So, all right, that number right there, pi over 3, is actually a little bit bigger than 1. So we're in this case, what's the limit as n goes to infinity of some constant to the n power if that constant's bigger than 1? This limit is infinity. Okay? So in this series, the terms just get bigger. This says the terms of the series just get bigger. All right? But what did the test say? The test said if this limit is not 0, it's conclusive that the series diverges. All right. So we'll say this one diverges all because of that. The fact that this was not 0. Now, as we learn more about series, you'll find that there might be more than one ways to look at a problem. We haven't really seen one like this yet, and we haven't seen one like this yet either. But we have seen one like this. Okay? So here's an alternate way to look at this. We have seen a problem of this description. This is a geometric series. Okay? R is what? Pi over 3. And as I was saying over here, pi over 3 is a little bit bigger than 1. A geometric series converges if r is somewhere between -1 and 1. And here in this geometric series, r is bigger than 1. So that is another way that you could conclude that it diverges. All right. Okay, so let's look at one more. Well, maybe two more, one or two more. Let's do, let me see. So I want to do this one. I want to save that one for last. Let's try this one. Okay, so look at that series. So let's say that we're seeing this series and we're trying to make a judgment on, does it converge or does it diverge? Okay, that's what we're going to spend most of our effort doing at this point in calculus 2. That's the way it works. Okay, converge or diverge. Now, so we know we have all these strategies, and so one thing we can do is try the nth term test. Okay, so that will involve finding the limit as n goes to infinity of that formula, whatever that is. So 1 over 4 to the n power. Okay, and there are different ways that you might do this limit. Limits is something you learn primarily in Calculus 1. Sometimes I give you some rules to use, and I remind you of some things that you learned in Calculus 1. But there's this rule right here. If a is some constant between -1 and 1, the limit as n goes to infinity of a to the n power is 0. So that's a rule that I could use to do this limit. 1/4 is between -1 and 1. So this limit is in fact 0. What can we conclude from the nth term test based on that? Well, let's see, what did the nth term test say from the beginning? The nth term test says this: if that limit is not 0, the series definitively diverges. If the limit is 0, the series can go either way, meaning it doesn't tell you anything. This is inconclusive. All right, so let's say that we tried this first, and we get that, and we say, oh, it's inconclusive. All right, it doesn't tell us. It doesn't tell us anything. So now we need to figure something else out. How else can we figure out if this series converges or diverges? Well, so what's our second strategy going to be? Maybe then we realize, oh, it was a geometric series this whole time. This is a geometric series, right? And r is 1/4. So that means it converges, okay? So I tell you this because I was pretending to not realize it was a geometric series, because I wanted to say that you might try the nth term test. You might calculate this limit. You might get 0, but it doesn't tell you if that series converges or not. The 0 is inconclusive. If you got something different than 0, then it would tell you definitively did it diverge. Anyway, so that's the first thing I tried. It didn't work. Then second thing I tried is, well, I realized it was geometric. R is 1/4, and any geometric series will converge if R is somewhere between -1 and 1. Okay, let's try one more, and then I'll give you some final notes and thoughts about this. See, this one, that one looks complicated, but all the nth term test says to do is calculate this limit, okay? So if I can calculate this limit, and if I get something besides 0, that would be conclusive that the series diverged. That's what that nth term test said. Now, I'm hoping that that looks a little bit familiar to you, because in my video on sequences, I gave you this formula. Limit n goes to infinity 1 plus a over n to the n power. A is any constant. Okay? The result of that limit is e to the a power, where e is a number with its own special purpose. It's about 2.718. It's used to calculate compound interest and population growth and so on. All right, so there's our limit. That's what we want here. I mean, these look identical. 1 plus 2 over n to the n power as n goes to infinity. So that's going to be e squared. Now, I don't know exactly what e squared is, but if e is 2.7 and you square that, that's definitely not 0, okay? And that's all I needed to know, was that this limit wasn't 0. What conclusion can we make? We can conclude that this series will diverge, okay? All right, now I don't think it's hard to use the nth term test. You might get it confused later on, but if this is all we focus on right now, you're probably okay. Let me show you one more thing about this that I think is worth emphasizing before we go on too much further. I made a special video just on this, but it's worth reminding people. Don't forget, a sequence and a series are two different things. They're two different things that seem very much alike. All right? So this is a sequence. A sequence is what? A sequence is just a list of numbers. This sequence is 3 for the first term, 4 for the second term, roughly rounded to 4.6, then rounded 5.1. You keep going like term, like say ... Term 147 is about 7.29, and term 148 is also rounded to about 7.29. This sequence actually converges to e squared, all right? So when I just did that limit, when I found limit here, 1 plus 2 over n to the n power is e squared, that just tells me that this number starts to look, a lot more like e squared the bigger the n is. So the further down that list you go, the more the numbers look like e squared, which is about 7.3. Okay, so this sequence, the list made by that formula, converges to e squared. You can look at it. You can calculate these terms and see that the further down the list you go, the more they look like that. This is a series. This series involves exactly the same numbers as this sequence. Exact same numbers. What's the difference? They're all added together forever, all right? So the series diverges as we just concluded, and you can look at the partial sums. I mean, here's the series, 3 plus 4 plus 4.6 plus 5.1. Add the first 2 terms, you get 7. Add the first 3 terms, you get 11.6. Add the first 4 terms, you get 16. Does it look like it's converging? Does it look like the more terms you add, the closer to something you actually get? No, the more terms you add, the bigger your answer is every single time. Okay? That's what we mean when we say the series diverges in this case. So the sequence looks a lot like the series. They're different. The sequence converges. The series made from exactly the same formula and numbers diverges. Okay? So just as long as you can tell they're different and keep that in mind, then you can avoid confusion later on.